Let us look at the second paragraph now. So for the second paragraph, we have ligands like Cn minus and CO are sigma donor and pi acceptor because of the presence of vacant antibonding pi star orbital. So it should be noted that more electronegative atoms shares bonding character and less electronegative atoms have more antibonding character. The strength of the back bonding, which starts from the central metal atom and formed by pi star molecular orbital of CO or Cn minus, depends upon the number of valence electrons present in the central metal atom or metal ion. So let's start with question number 34 now. Consider the following statements which are about the binding affinity of a pi acid ligand with a metal atom or ion which can form a coordinate bond. So if you look at the first statement now, CDS in the solution of KCN is less soluble as compared to CUS. So students, this statement is correct and it is in fact used as a differentiating reaction to separate Cu and CD. So we have CUS and we have CDS. So when added to Cn minus, the copper, which has a high affinity for the cyanide ions, it dissolves due to the formation of a more stable complex. However, the CDS, when added to Cn minus ions, it does not dissolve. So CDS is not very soluble in cyanide. Let us look at the B option now. CDS is precipitated when CdCN4 2 minus is allowed to react with H2S. Students, this statement is correct. The CD2 plus ions have a greater affinity for sulfide ions. So there is a greater affinity for sulfide ions as compared to the complexation with cyanide ions. So it will be precipitated when the complex is allowed to react with H2S. So statement B is also correct. Statement A was also correct. Let us look at statement C now. Hg2 2 plus ions disproportionate when KCN is added. So students, this statement is also correct. Hg2 2 plus ions, when it is allowed to react with KCN, it undergoes disproportionation to give us liquid mercury or metallic mercury plus HgCN whole twice. So statement C is also correct. So students, we can see that all of these three statements are correct. So we have to mark option D as the correct answer to our question. Let us look at the next question now. Question number 35. So color of freshly prepared solution of KFeCrCN6, in which the oxidation state of Fe is +2, whereas the oxidation state of chromium is +3. So it changes from red to green on long standing. It is due to. So the examiner is interested in knowing why the color transition happens. That is why the complex turns from red color to a green color on long standing. So if we try and look at the structure of this complex. So we have chromium +3, which is bonded to the carbon, whereas the lone pair over nitrogen is bonded to the Fe +2. Now if we look at the cations first. So Fe +2 is a soft acid, whereas chromium +3 is a hard acid. And if we look at the cyanide ion, the negative charge on carbon is the soft center, whereas the lone pairs over nitrogen, it is the hard center. So from the hard soft acid base concept, we have that a soft acid, which is Fe2+, will like to bond with the soft base, which is the carbon, and a hard acid, Cr3+, would like to bond with the hard center or the hard base, which is nitrogen. So given some time, this will rearrange itself to give us the other bonding which is mentioned to us in the question. So chromium 3+ ions will be bonded to the lone pairs of nitrogen, whereas the Fe2+ ions will be bonded to the negative charge over carbon atom. Let us look at the A option now. Formation of KFe3Cr3CN6. So students, in this option, the examiner has oxidized Fe2+ to Fe3+. So this is incorrect. No such oxidation happens in this structure. Let us look at the next option now, option B. So there is a change in linkage of Cn. In red compound, the Fe plus 2 is bonded to N, and green compound it is the opposite. So students, in this option also, we can see that the examiner has oxidized the Fe plus 2 to Fe plus 3. So this sort of oxidation also does not happen. This statement is also incorrect. Let us look at option C now. Change in linkage, that is in red compound it is Fe plus 2 bonded to N and Cr plus 3 bonded to C. Whereas in the green compound, it is the other way around, where the Fe2 plus, which was a soft acid, it is bonded to the soft center, the soft base, carbon, and Cr3 plus, which was the hard acid, it was bonded to the hard center or the hard base, which is nitrogen. Students, statement C is correct. And let us look at option D now. Decrease in CFAC as the red compound changes to green. So students, no such thing is going to happen in which there is a decrease in CFAC value. The complexes always try to arrange themselves in such a manner that the CFAC is maximum. So option D is also incorrect. So students, we have to mark option C as the correct answer to question number 35.